Hello everyone, in the last video we established variables and being able to assign them and modify them from directly within our dialog files. So now let's put those variables to good use and create a new logical line that can evaluate them and use them in conditions and expressions so that way we can add more dynamic elements into our visual novels. Let's get started. First thing we want to do is we want to make that new logical line. So let's create a new script which is going to be ll underscore and we'll call this condition. Now how we're going to write these is we're going to do it similarly to how you write it in code. We'll start with the if word and we'll have our condition inside of parentheses. This will be the basic format that defines the conditional logical line. So we'll then have our expression inside which can be evaluated to determine whether it's true or not. So when we have this, we can then create encapsulators which will contain all the lines that will execute if the condition is true. This means we're going to be using both the expression and the encapsulation segments and classes within the logical line utilities. So as we create this LL condition, let's make sure that we use those namespaces. So using static dialog.logicalLines.logicalLineUtilities.encapsulation, and we also want expressions. Another thing we can do is we can tell it what to do if the condition is not true. So we'll have an else line, and inside of there will be lines that are executed if else or if the condition is not true. And else will be completely optional, but it will still be a factor to be considered within this line. So our keyword for this line is going to be if. And we're also going to have another one. Private constant string else is going to equal else. Now this line will only be true, will only match it if we can return true on this factor. If the line that we are looking at, if the raw data dot trim, just in case we have any tabs or anything, let's remove all the white space. If that starts with our keyword, then we know this is a condition line. So how do we know what condition it is that we're looking for? As stated, the condition is going to be contained within parentheses, so we need to extract the condition and only the condition. Let's make a new variable here for a private constant string array for the containers. This will contain the condition, and that's going to equal a new string. Actually, that can't be a constant. Well, can it? You know what? I don't even know. Here's a learning point for us all. No, sure can't. I didn't think so. So it's got to be a read-only. We'll make it a read-only, and then we'll have inside of here the two items that we'll be looking for. We'll have the opening bracket and the closing bracket. So let's go ahead and make a way to extract the condition. We'll make a new private function which returns a string, and we'll call it extract condition. An extract condition is going to take the line that we're looking at. So let's find the start index of the actual condition. This is contained inside of the parentheses. So int start index equals line.index of, and we're going to get it as the index of that first character. So containers 0. But we want to add one because we want to come right after the container. So we want to start literally at the first character of the condition. And then let's find the end index. That way we can rip it right out. So int end index equals line.index of containers 1. We're looking for that one. And now what we're going to return is the line.substring. So we're going to rip it right out and take it from starting at the start index and end it at wherever that ending index would be. So dot trim to trim all the excess off, and we're good. Now we can extract the condition and evaluate it. So if we determine that this is a match and this is a conditional line, we're going to call the execute function. And execute needs to first extract that condition, so we'll say string raw condition equals extract condition, and we're going to take it from the line.rawData. And at this point, it has not been trimmed yet, so let's go ahead and trim, even though it's really not I guess it's not necessary because we're just looking for the indices of the container items, but I'm going to trim it anyway. It's not any overhead I'm concerned with. And now we need a way of evaluating if the condition is true or not. So we're going to get that in a Boolean, but we're going to need a function that we can call to determine whether that is true. So we'll have this inside of our utilities as well. So let's jump to that real quick. So inside of our utilities, we've got a class for encapsulation and expressions, and while conditions could go with expressions, I don't think I'm going to put them inside of it. I'm going to make another one specifically for conditions. So public static class conditions. So our first function is going to be to evaluate a condition. And we're going to check and see whether this is true or not, whatever we're looking for. So we'll make public static Boolean returning function called evaluate condition. And this is just going to take in a string for the entire condition that we'll be looking at. So we know that our tag manager can go ahead and find and inject the actual value of any variables, which means our variables can be injected directly into the conditions. So if we run a line like narrator, my value here is Boolean, which should be true, then that's exactly what we should get in the output. But for conditions, something very important is that we can negate the Booleans. And we're already taking that into account when we're trying to, assign them. But what about when we're trying to inject them? And that's because when we're assigning values and using the operator line, we are grabbing all the variables manually and checking if they have that exclamation point, and then we go ahead and remove it and negate the value. But the tag manager is not doing that, so let's make it do that real quick. In inject variables, the way that we can go ahead and remove that little exclamation point is we will also add the exclamation point into the trimming factors, which will now identify the Boolean, but you'll notice it's not negated. To negate it, we need to check the match value and see if it starts with that or not. So we can do that real simply. If match.value.starts with that exclamation point, then we know that we need to negate it. So we'll have bool negate equals whether that is true or not. Now, if that's true and we've gotten the variable, now let's see if we can negate it. So if negate and the variable value is a Boolean, then variable value equals, we're going to do the negation, make sure that we treat it as a Boolean, and just specify that it is the variable value that we are changing. And like that, we can now inject the Boolean and negate it if it needs to be negated. Which means this is now prepped to find our conditions and inject all the values in there. So when we evaluate the condition, let's just go ahead and say that condition equals our tag manager dot inject, and we're going to inject the data into our condition. Now, we're going to say that inject tags is false, because we don't want to treat, will we? You know, maybe we can throw tags in there. Yeah, maybe we can throw tags in to be conditions as well. Okay, so we'll leave that as true. So we'll leave tags, we'll inject tags, and we will also inject the variables. That just means that we can use tags as conditions or condition parameters as well, which I wasn't thinking about that until just now. Okay, so now that we've got all our variables in place, we need to figure out exactly how we're going to be determining these conditions. So we could have a condition that is just a Boolean, And if that's true, then we'll go ahead and run it. Or we could have like a variable that is just one single condition. So maybe we're checking if something is greater than or if it's less than something. But we can also pair conditions together, just like you could do in regular code. So we could have one variable on one side and we need to make sure that both of these are true together. Or we could separate that for or, and we could do that either way. We could do any of the standard operators. So we could also do not equal, so as long as they're not equal to each other, or as long as they are equal to each other, or maybe one is less than or equal to. You get the picture. We can do all these different pairs, and we need to figure out if these pairs are true together. So that means we need to split this condition into all of the parts and those little evaluations. So we're going to use regex, and I have a line here. Well, not that line. That line. This has the conditional operators that we'll be using. So we have equals, or we have not equals, or we have less than equals, greater than, less than, greater than, and an or needing to be backslashed each time. So that is our regex operator, where we can split each parameter of the condition by whatever evaluation is going on. So let's split our condition into the different parts, and then we can check it and evaluate it from there. So string array, we're going to call this parts and set that equal to regex.split. We're going to split our condition, and we're going to split it by the regex conditional operators. Now, we're also going to select each item and we're going to trim them, because if we're just splitting by not equals or anything in that array, then you can see as we have space here on either side, we would be getting all the space. So we want to make sure that we trim each item. So let's go ahead and say .select, and we're going to select each item as P, and then what are we doing with P? We're going to say P.trim. We're going to trim each element that we're doing. And then we just need to convert this to an array. Now, any string values that are being injected from variables, they're not going to be inside of quotes. Such as if I define a string inside of quotes and then tell the narrator to repeat whatever that string is, then we just get the line and we get the value, but there are no quotes because the string value is not stored with its quotes. So if I have a condition here, if string equals my string, then I'm going to have one side with quotes and one side without. And sure, we can go ahead and parse this into a string, which we'll do. And this side is not going to have them. But we're going to want to make sure that we remove the quotes from any variable that is, or any value that's given in the condition. That way, when we convert them to a string, everything's working together and it's all working right. And we don't have some with quotes and some with not. So after we get all those parts, let's do a basic for loop and iterate through each one of those parts. And let's just check if they start and end with quotes. So if parts I dot starts with, and we're wanting to see if it starts with the quote, so we need to backslash the quote, and parts I dot ends with, and let's look at if it ends with a quote as well. So if it starts with a quote and it ends with a quote, then let's go ahead and say that parts I equals parts I. We're going to get the substring, and we're just going to start at the first index, so we skip past the first quote, and we're going to end it at the parts I dot length minus 2, so we come just inside of the ending quote. So we essentially strip the quotes off of our strings. And now we're ready to test the condition. So if we're just passing in a Boolean, we shouldn't have to say whether that Boolean equals true or not. We should just say if Boolean or if not Boolean. So we're going to assume that if it's just a Boolean, then there's only going to be like one part inside of our condition. We won't have anything split, so let's see if parts.length equals 1. If there's only 1, then let's try to parse it as a Boolean. So if, not false, if bool.parse, let's actually try to parse. If bool.try parse parts 0. Let's get the result to outbool result. And if that's true, then we're just going to return whatever the Boolean actually is. Otherwise, then we really don't have any kind of complete condition. We could return true because there's nothing to compare it against, or we could return false. But I'm going to return false, and I'm going to return an error telling me that something's wrong. And I need to check out my stuff because I obviously typed something wrong. I'll make that a simple debug log error that says could not parse condition. So that's if we only have one part. So let's start with if it only has 3 parts, which means we have one value and a evaluation operator and another value on the right side. So else if parts.length equals 3. Then we need to evaluate this expression. Now, this is where it comes to the point where we have to parse the value and determine if the left side is matching the right side given the evaluation operator. We have to do that switch for whatever kind of variable type that we're supporting here. So that's going to be a little bit large for putting in this block of code. So I'm going to stick it outside and we're going to have a new function. We're going to make this a private static bool called evaluate expression. And the way we'll do this is we will take a string for whatever is on the left, and we'll take a string for the evaluation operator, and we'll take a string for whatever is on the right. So we could go through and we could try to parse each one of these things into a Boolean or an integer or what have you, and then do like a check for the and or the or, the equals or the not equals. But I'd like to be a little more organized than just having a big old statement here with a bunch of duplicated code. So we're going to do this using dictionaries instead. By using dictionaries, we'll be able to set the key or the value as the operator. So no matter what our left and right is, we're going to look it up in a dictionary by this operator type. And that operator will be able to make a different dictionary, whether it's an integer, a float, or a Boolean, or what have you. And by looking up the operator, it will then perform the correct operation on the left-hand side and the right-hand side. So let's go ahead and get that dictionary system ready. We're going to have a type of data. So the type of data that's going to be in this dictionary is we're going to have a string for the evaluation operator, and we're going to have some sort of function or operation. So our operation is going to be a delegate, which will return us the value that we're looking for, which would be whether the condition matches or not. So let's just make it private delegate Boolean, and this we'll call it the operator function. So operator func. Feels funny every time I say that. So operator func. And then we're going to have just this generic type, because it can be a Boolean, int, whatever, left, and then whatever is on the right. And now let's make our dictionary. So our first dictionary is going to be for our Booleans. So we'll have a string for the operator type, and then we'll have the operator func of the type Boolean. And this will be for our bool operators. We'll make that a new dictionary, and as we define this dictionary, we're going to initialize it with some values. The first thing we want to do is we want to make the pair, and we want to define the operator that we're going to be using. The first one will be and. So we want to make sure that both the left and the left and the right are true together. So we will have left and right being passed in, and we're going to evaluate them by checking if left or left and right, rather. So if that is true, then the left and the right are both equal together. Okay, let's make another one. The next thing we can do with bools is or. So we could have or. That's our next operator. Again, we're going to take the left and the right, and then we're going to see if our left is true or our right is true. We'll do the same thing for equals equals to make sure they're both equal to each other, and not equals to make sure that they are not equal to each other. That can work for our booleans. So the way that we'll evaluate our booleans here is we'll go ahead and parse them and then evaluate them against that dictionary. So let's see. If bool.tryParse, we're going to take a look at the left one and try to cast that to a bool of left bool, and bool.tryParse right out bool right bool. If that's true, then return our bool operators. We're going to look it up by the evaluation operator, and we're going to pass in the left bool and the right bool. No matter what our expression is, we'll be able to determine if it's true using that method. Next thing, we'll make one for our floats. So we'll have our float operators, and that will be able to support equals, not equals, greater than or equal to, less than or equal to. And then we'll go ahead and try to parse them out as floats and return the result of the float operators using the evaluation provided. And we could just copy the float dictionary, but change it out for integers, and then we've got our integer operators. And we can do the same thing, copy the line for the float, paste it for our integers, and just swap out any reference for float for integers. And also rename left float to left int, and right float to right int. And make sure that float operators is int operators. Now, as for anything else we're going to assume to be a string. So we'll just switch by the only two operators that we can run with a string. So we'll switch the operator, or the evaluator, and we'll check if the case is equals, and if it is equals, then we're going to return left equals right. And then if the case is not equals, then we're going to return left is not equal to right. Otherwise, we're going to default, and we're going to throw a new invalid operation exception. And inside of that, we can just give ourselves a little message that'll say unsupported operation, and just show us what the operation is with OP. If you want to add a little safeguard in here for yourself, then what we could do is, if we decide to float and try to parse it, then what happens if we just do something ridiculous and try to see if a bool is greater than a bool, which can't work. And greater than or less than is not even defined within our Boolean operators, so we would get an error here. But if we want to handle error handling, then what we could do is first check if bool operators contains key, OP, and only then will we return that bool operators. And we could do that for the rest of these lines if we so choose. Now for me, I'm just going to trust myself not to make that kind of error, so I will leave it as it is. And that means we are free to head back up into our evaluate condition. So if the parts.length is 3, meaning we only have a left and a right and an operator, then we'll go ahead and try to evaluate the expression of all those together. Okay, so then let's go ahead and return evaluate expression, and we're going to take parts 0 as the left operator, parts 1 as the evaluation operator, and parts 2 as the right-hand value. Anything other than that, if we have more than 3 parts for the basic expression, we'll just treat it as something that is unsupported, some unsupported format. And if that's the case, I'm going to log an error and just return false. So back in our logical line, when we have execute, we can go ahead and grab this condition as well. since we're using are we using anything in expressions? I don't think we actually are. Yeah, I don't think we actually are. We're just using conditions because I didn't put that inside of the expressions namespace, so we'll just change that to conditions. And we'll go ahead and get a boolean for our condition result and set that to equal evaluate condition, and we'll pass in the raw condition. Great. Okay, so with this logical line, like I said, we could have a if part to this line and also an else part. So no matter if the condition is true or false, we still need to figure out if there's something to execute. So we'll grab that from whatever conversation is currently running, and we can grab that as conversation, current conversation, which is equal to our dialog system. Conversation manager dot conversation. There's our current conversation, and let's also get the progress of this current line. So current progress equals dialog system dot instance dot conversation manager dot progress. Now we need to extract the if data and the else data as well. As I said, whether the condition is true or false, we will have the if condition up top, and we will possibly have an else condition down below. It may or may not be there. So let's first get the if data. So we'll grab this since we're using encapsulations up above. Encapsulated data, this is going to be the if data, and that's going to be equal to rip encapsulation data from our utilities. We're going to pass in the current conversation, and we're going to pass in the current progress, and we are also going to say rip headers and encapsulators should be false. The reason is we don't need to rip a title like we did for choice. So all we need are the lines to be executed inside. Now let's also get the else data. So encapsulated data, else data equals new encapsulated data. We're not doing anything with it yet because we need to see if it's there. So let's go ahead and take a look at this. If data, let's look at the ending index and see if it is within the, if it's still within the length of the conversation. So if data dot ending index plus 1, let's check the line directly ahead of it. If it's less than the current conversation dot count, then we know we have lines that are proceeding after the if statement, and an else line may be one of them. So let's see what the next line is. String next line equals current conversation dot get lines, and we're going to grab the line with the if data dot ending index plus 1, and we'll trim it just in case there's any white space there. So let's evaluate it. If next line, we need to see if it's equal to else. So if next line equals else, then else data equals rip encapsulated data, and we're going to pass in the current conversation, and we're going to pass in the if data dot ending index plus 1. And then we are also going to say that we are not ripping encapsulation headers here either. But if we do this, now we're going to need to make sure that we set the ending index of the if data to now be the ending index of the else data, since this has become a part of it. This is included in the entire encapsulation section within the dialog. It's all related to that if data, so we're going to change if data dot ending index to equal else data dot ending index. So now that we've ripped that, now let's figure out which one we're going to run based on that condition. So let's get our encapsulated data, selected data. That's going to be equal to, let's check our condition result. If our condition result is true, then we're going to run the if data. Otherwise, we're going to run the else data. And now, just to make sure that we've actually got lines, in the case of if we do not have any else data, if the selected data dot lines dot count is greater than 0, then we'll go ahead and queue a conversation. So conversation, new conversation equals new conversation, and we're going to pass in the selected data dot lines. Now let's change the progress of the current one to equal wherever it needs to pick up after this condition. So dialog system dot instance dot conversation manager dot conversation dot set progress, and we're going to set it to the cell data dot ending index. I think I could have just used conversation right there. Dialog. So dialog system. Let's now enqueue the conversation that we've just made. So dialog system dot instance dot conversation manager dot enqueue priority, because this needs to come first. And we're going to enqueue the new conversation. Then, to satisfy our enumerator coroutine here, we're just going to say yield return null. So this should run our lines no matter if our condition is true or if it is false, it'll run the correct lines. So let's go ahead and test that out. Let's define a variable. Our variable is going to be, I just keep going back to money. So money 50, it's just the standard at this point. So money equals 50. Now let's see if money is greater than 45. If it's greater than 45, then we're going to do something. And then I'll just have the narrator say after that's done with the condition. So if money is greater than 45, then narrator will say, you've got a lot of coin. And if it's not, we're not going to do anything. I'm not going to put an else block there yet. And as I run it, I can see that we have you've got a lot of coin shows up. Click it, and we are done with the condition. However, if I say that money equals 15, and then we run it, well, then we get, first of all, we had a little bracket show up. So we have the bracket that is showing up for some reason. And perhaps that's because we're only setting the progress if we actually have lines in the selected data. If we choose else and there is no else, then we're not going to be doing any of that. So otherwise, we'll go ahead and say that dialog system, or I'm going to use current conversation dot set progress, and I'm going to set it to the if data dot ending index. Come to think of it, that's going to be the ending index no matter if we have else or not. So what I could do is just set that up above, or I'll just make that right above the encapsulated data. And then we'll take it out right there and just run that no matter what. And now let's try that again. This time setting the ending index regardless of if we've met the condition or not. And it works. We can see we go straight to the end because the condition was not met. However, if we add an else block after that, then I can have the narrator say something. You can just say, you broke. And let's go ahead and launch this. There we go. You broke. And done with the condition. So after writing all this out, I gave all the code and what I was doing to ChatGPT and asked it to write a test file that would test all of the conditions for variables and input and all the evaluation operators and the assignment operators. So everything is within this file, and it literally runs a test for everything. So this will be available in the description so that way you can all download it and run it, because I certainly didn't want to type all this out. So that's going to be our next test. Let's go ahead and see and make sure everything returns the way it's supposed to. Okay, so I've got the little code box down in the bottom right corner, so that way we can see it running through all this. So let's go ahead and play. Okay, so the first thing that we get is we're looking for the input. So I'm going to go ahead and put in my input. I'm going to do Tony. What is your name? Tony. All right. So the input is Tony. It's wonderful to meet you, input gunk. So we can see that that didn't work. And this is a good reason why we run all these tests. Helps us find things that otherwise we wouldn't catch. Because I inevitably skip over some things, as careful as I try to be. So this is because in our extract value function within the logical line utilities of the expressions class, if we come down where we do our string, we are injecting the variables and we are injecting the tags, but only if it's identified as a string. So we go ahead and identify the string and we remove the quotes, but we inject the values. However, if there are no quotes, even if it is a string, if there are no quotes, it's going to come down here. It's going to see it's not an integer, not a float, not a boolean, so it just returns the straight up value. So firstly, let's go ahead and say that value, let's just copy this. Value is going to equal the value, but we're going to inject the tags and the variables into it. And let's run this again, and it should go through this time. So what is your name? Tony. The input is Tony. Perfect. It's wonderful to meet you, Tony Gunk. Give a like if you know that reference. Okay, so now we have var equals 1008. So that is coming from this line, var equals number 1 plus number 5, which is 6, plus number 2 is 8 plus 1,000, 1008. So all of our assignment there is working. And then we're going to say, we're going to give Raylene and Stella their own database values with variables called love. So whoever we make the choice here, we're going to increase their value by 10. So I'm going to choose Stella, of course, because she's my character. And then once we come to the condition, if Raylene.love is higher than Stella.love, then we would execute a condition saying that. But because it wasn't, we went ahead and said that the affection with Stella is higher than Raylene. Okay, so now we come into test comparisons. The first thing is we are looking if our Boolean true is equal to Boolean false. That should be false. So test comparisons, bool true is not equal to bool false. This is correct. Number 1 is not equal to number 2. That's correct. Number 3 is greater than number 2. That's correct. Number 1 less than number 2. Again, correct. 3 is less than or equal to 3. That's correct. 5 is greater than or equal to number 3. That's correct too. So we can see that everything looks like it is working good. Arithmetic operators. So number 1 plus 1 is number 1. That should be number 2. Okay, that's interesting. So what happened there? Variable number 1 not found in string assignment. So if I enable the variable store testing and print the database, first thing I notice is that we have a database called number 1. And if I look in the database default, we do have the variable number 1, which does equal number 2. So my question is, why did it generate this database? So as it turns out, if you remember when we created our variable store, if we define a variable followed by a dot, followed by something else, it will automatically create a variable, and whatever's on the right side will become the variable of whatever's on the left side, the database. Since number 1 is at the end of the sentence and it has a period there, it's being treated as a database and it's being created with no variable. So that's something that we need to fix real quick. So we need to check first when we're injecting the variable through the tag manager to see if it ends with any kind of illegal character. And that would be our little dot. So we can say bool ends in illegal character equals, we're going to check and see if our variable name dot ends with, and we want to see if it ends with that relational ID that relates the database to the variable, which is the period. But that's defined here, and just in case we change that in the future, I'm going to make this public. It's still a constant, so we can't change it, but what that does mean is we can now reference the variable store dot relational ID here, and that is the illegal character. So if ends in illegal character, then our variable name should equal the variable name dot substring, and we're going to start at the very beginning, so we're not cutting out anything at the beginning, but we are cutting out up to the variable name dot length minus 1. So we're cutting out the last variable, or the last character. And that should get our variable to where it can be identified. And then as for when we remove this, let's go ahead and say if ends in illegal character, then length to be removed minus equals 1. because we're not going to remove that character at the end. And let's run this again. So we are now at this line. Number 1 plus 1 is number 1, ending in that period because it's the end of the sentence. Now let's go ahead and click. There we go. Number 1 plus 1 is 2, and we still have the dot. So that is correct. Let's go ahead and proceed on with the rest of the file because everything else should be true. Number 2 minus 1 is 1. That should be 1. Good. Number 3 multiplied by 2 is 6. Should be 6. Good. Number 5 divided by number 1 is 2.5. That's good. And the unary operator. So negation of bool false is true. That is correct. And then the string comparison. String 1 is equal to string hello. So what was string 1? String 1 is hello. Yes, so that is correct. And then string 1 is not equal to string 2, which is world. So that's correct. String hello plus string 2 is hello world. Yep, so we get hello plus world. There we go. Everything is working. So that concludes a very long and complicated video on adding variables and conditions to our dialog files. But the system is set up, and it's even expandable if you want to add your own variable types. Just remember to create your own dictionaries and give them their operators and what they do. So this will allow us to add much more dynamic capability into our novels. Like I said, I'm not expanding this too much, so we don't have multiple conditional checks in one statement because we should keep code to code and dialogue to dialogue files. So we're minimizing these so that way we don't start programming in our dialogue files, but we do have enough so that way we can go ahead and, just make small changes, make small differences in the files. And I've still got up. Yeah, the reason my console was popping up all those lines is because in my conversation manager, I just had a debug statement there. So I just forgot to take that off the screen. So that's that. We'll load new chapter files when there are large continuous changes that are ineffective in a choice or something. But we'll add these conditional statements and variables for if they're small things, or variables if we want to keep track of them over time and throughout the different chapter files of this visual novel. So this really opens it up for us. But that concludes this episode, and I will see you guys in the next one. Bye.